Continuamos entonces con Zarka Mukhtar y Andrea Andreoli, de la Universidad de Bolsano, Italia. Zarka Mukhtar es licenciada y magíster en Geografía, con especialización en Geografía Física del Government College University de Faisalabad, Pakistán. Actualmente es estudiante de doctorado en el Departamento de Montaña, Medio Ambiente y Agricultura, con especialización en investigación glacio-hidrológica en el Himalaya, en la Universidad de Bolsano, Italia. Su trabajo de investigación se centra en el seguimiento y cuantificación del transporte de sedimentos en ríos mediante técnicas de teledetección. Específicamente, la investigación aborda la metodología espacial y temporal para la evaluación, estimación y mapeo del transporte de sedimentos y cambios geomorfológicos en las cuencas de los glaciares del Himalaya, considerando también condiciones meteorológicas, y utilizando imágenes satelitales de alta resolución. Por su parte, el doctor Andreoli es ingeniero forestal y de medio ambiente, graduado en la Universidad de Padua en el año 2002, ha trabajado como consultor en proyectos de gestión de parques y reservas protegidas del Estado de Italia y para las agencias de cuencas de grandes ríos italianos. Realizó su doctorado en la Universidad de Padua, aprovechando de un intercambio con la Universidad Austral de Chile en Valdivia, donde llevó a cabo una investigación sobre el rol de los elementos leñosos en cauces de montaña de las Dolomitas italianas y de la cordillera de los Andes. Actualmente continúa investigando en el campo de la morfología fluvial, es autor de varias publicaciones a nivel internacional y ha trabajado como investigador principal o adjunto en varios proyectos nacionales e internacionales. Desde 2014 es profesor asistente en la Universidad de Bolsano, y hoy los investigadores nos darán su exposición con título Monitoring Morphological Changes in Himalayan Proglacial Rivers through a Semi-Automated Classification Approach.
Hello, everyone.
Hello, Zarka. Can you share your presentation?
Can you see the screen now?
Yes, we can see it now.
Yeah. So, hello, everyone. Myself, Zarka Mukhtar. Thank you for introducing me. And now I'm going to present the topic, monitoring morphological changes in Himalayan proglacial rivers through semi-automated classification approach. So let's get started. The things I'm going to discuss, I'll describe my PhD project briefly, and then I'll jump toward the current the focus, which is a little chunk of the project, and the aims, objective, research question, where I am focusing and to accomplish my aim, and what are the material and methods, the preliminary results, and what are the struggles and problems I'm dealing with to resolve the problems. So basically, I'm focusing on a proglacial system, the areas, the morphology just next to the glacier snout or ice cap, ice caps or ice sheets. But within the proglacial system, the major focus is on the proglacial rivers, how they are, because of continuous glacier melting, global warming, excessive runoff, what are the effects of sediment transport on the river morphology, how they are changing, either they are expanding, evolving of new river channels, or thinning or extinction of the rivers. So the major things is to understand what are the past decadal changes within few focused proglacial rivers in Himalayan belt, and based on this, what would be the future of these rivers next. And the most important part is to build a new conceptual model for Karakoram Himalaya, specifically because there is no specifically designed hydrological model, glacial hydrological model on Himalayas. We are having a lot of other models designed on other glacial ranges, and we are using it on Himalayas. They're working well, but till there is a need to develop a specific model for Himalayas. So the current focus is to understand what are the past decadal changes since 2 decades in the in the river, proglacial river morphology, and how the climate and glacier melting is affecting the morphology of the rivers. Either they'll evolve or they'll extinct in future. Here I have an example of similar work, which is done on a glacier in Solheima Jökull. I hope I'm pronouncing the name right, in southern Iceland. And this is a similar kind of work which has been done on proglacial landscape, which is covering almost all the glacier landscape. What are the morphological changes since 1960 to 2010? According to our focus, the proglacial rivers, which is giving a stable result since 1960 to 1996 almost. But since 2000 to further, we can see there is more braiding, channel braiding and elevation changes. We can see from 2001 to 2010 in the river. So similar kind of work we are we have aimed to work on in Himalayan proglacial rivers by mapping and identification of multi-temporal planform changes in the proglacial rivers and lakes. And then based on these results, they needed to interpret with deglaciation and climate change, how much they have the impact on this. And also another important thing is to compare the response of high debris cover glaciers and low debris cover glaciers. For the sites I have selected from on this map, you can see this is a huge Himalayan belt, the third pole of the world, where I have focused on 4 major locations. One from Pakistan, second one from Pakistan is the Gyeong Glacier, Saltoro River, and the second one is a disputed territory, Kashmir, Siachen Glacier, Nubra River, and the third one is from India, Gangotri Glacier, Ganga River, and the fourth one is from Nepal, Langtang Glacier, Khola River. For this, I am using a digital elevation model of 12-meter resolution. My all research work is done on satellite images, remote sensing stuff. So and very high resolution images. I describe further for the need of high resolution images. And then the satellite images of different resolution to compare the results with 30-meter resolution, 10-meter resolution, and 2.4 meter resolution. Landsat 5 is for 30, Sentinel-2 is for 10, and the other 3, WorldView 2, QuickBit 2, and Iconos for 2.4 meter resolution. I'm using all these satellite sources because of different reasons. First one is there is no continuous coverage is available within one satellite source, so we have to rely on other satellite sources also. And the other one is the high resolution to get the to extract the river channels in like this. These remote areas and thin rivers are needed to be extracted in a proper way, a proper manner. So high resolution images help to extract the proper channel morphology. So all these sources are used to compare the results, how similar and how better results they are giving, and also to have the past dynamics of rivers, vegetation, and sedimentary bar since 2000 to 2020. And by using all these materials, DEM is actually I'm using for valley bottom extraction, because the classification, the model is applied on broader areas, and then to extract the major, just focused part of the river, valley bottom extraction. For valley bottom extraction, the DEM is used. And for the classification, for the modeling, I am using Google Earth Engine platform with the JavaScript API to design this the supervised classification model. And satellite images are basically used for mapping and identification of the changes through time and space also. So within all these material and methods, the classification model, which is the most important task I have been done yet now. So this is the model which is designed on Sentinel-2 for the preliminary results for the testing of the model application. It was designed on Sentinel-2 images because it is freely available, and we have a lot of we can have a lot of images to test it on. But for the other satellite sources, these are expensive. We need to buy it. So it's better to test the model first on Sentinel-2 images and then to make the models for other satellite sources also. And for this, by taking the Sentinel-2 images, I calibrated the model on Nubra River, which is Siachen, the most important and complex river. I mean, the complex and very interesting river. So I designed this on Nubra River, and I trained the model by taking the maximum training samples from Nubra River, glacier, Siachen Glacier, and then I divided it to 17:30 ratio to validate, to calibrate and validate. And also, after testing to all the images of the selected channels, I also tested on other images other than the selected regions to test the performance of the model by taking new validation samples. Within this work, these are the results for just one location, Nubra River, but this model is also tested on other locations, Langtang, Gangotri, and Gyeong rivers also. So this is like Landsat images are taken just for primary use to have a manual interpretation, you can say, but later on we decided to make a model also to check it, how it works, to compare the result reliability with others. So this is 30-meter resolution, and the rivers which are classified, rivers and sedimentary bars, which are a bit exaggerated than they are originally, but with the manual interpretation, it's giving an idea. So the other two sources with 10-meter resolution and 2.4-meter resolution, they are giving almost same results, very well predictable, very well interpretable results. Other than this, if we compare the resolutions of Sentinel-2 or WordView 2 or QuickBird 2, you can see at the right there is a zoomed portion of a QuickBird 2 classified image, where you can see there it is even highlighting the minute pixels of water also. And at the right, the zoomed portion is from Sentinel-2, which is almost it is covered within the vegetation portion. So the minor portions of minor pixels of water is not highlighted here, which is good for my need for this classification. It is it is good because when I need to calculate the area changes, that minute pixel can create the ambiguity in the results, and in that case I need to get rid of this thing. So overall, till yet, the model is working perfect. It's giving the accuracy with all these models, Landsat 5, QuickBird 2, Sentinel-2. These are the 3 satellite sources, which is giving 93-94% accuracy, which is not bad. And this is the area calculated within the Nubra River changes from 2000 to 2020, which is not giving any proper trend. There is up and down continuous, but there could be one reason, like I'm using the satellite images from different months and different dates. There is no continuous consistent data available, so we need to rely on different dates and different months. Because of this, there is also a problem to have a proper trend in the changes. And yeah, this is one of the reason I'm trying to deal with, to have other images of at least the nearer dates to get rid of this problem. So it's not still, it's not yet all done. Still, there are a few modifications needed to be in model. As I said, I have designed the model on Nobra River just by using one location. But then after having the results, after having few problems in the results, I got to know, okay, I need to modify the result by modifying the testing samples. I'm mixing all the pixels as much as the satellite images I'm using from one satellite source. I need to take the samples and mix it to have good accuracy of the results. And the one solution which I mentioned in the last slide by the mixed pixels of water and vegetation, how I could resolve the problem. The solution is to take the polygons other than the single pixel, so it can reduce that problem. And then after modifying all these problems, tested on broader scale, other than these locations which I am not using, but by testing the model on other images also, it can give a broader idea how the model is working after the modifications. And till now, the major problems and struggles I am facing is accessing the satellite data. I'm working on very complex regions, proglacial regions, which are very remote. And in my case, the political restrictions are also very much big problem to access the data, in situ data. Because Pakistan, India, Kashmir, these are very critical regions where you cannot access. For example, Siachen is a very complex area to go for. So accessing data is also a problem. And secondly, the satellite data, which is not continuous and consistent, very few coverage is available. And then the high resolution data is another problem because it's so expensive. Sentinel-2 is giving good results, but the coverage is not available before 2015. And for the other satellite sources, if you rely on, for example, WordView 2, QuickBird 2, all these images, they're having few coverage, still not too much, but the coverage, sometimes they are giving the options by joining two images. For example, to cover one area of interest, they are joining. The left side is from 2003 image and right side from 2010 image, which can create the ambiguity in the results. Not that much reliable result we can have from it. So this is another problem. And yeah, so these are the problems still in process. We are trying to get rid of and get the better results of. Thank you. This is it.